So this is the third video for our heights right triangle trig. This video will take you through slides 17 through 25. So we're going to look at the ratio of sides of similar right triangles. All of them are similar because they are 90 degrees and 50 degrees by angle similarity. So we're going to look at different sides and how the ratio of those sides are going to be the same. Okay, so let's start with the blue triangle on the left. The length of the side opposite 50 degrees. If you imagine an invisible line going all the way across, you have 3.74. So opposite means across from. Hypotenuse is always across from 90. It's the largest number, so we have 4.9. And then make sure that when you are typing in your ratio, you put the opposite at the top and divide that by the hypotenuse. Don't flip them around and then hit enter. And you will see a decimal equivalent. Now we're going to do the orange triangle. Again, go to the 50 degrees. The length opposite is 4.58. The hypotenuse of the orange triangle is 5.97. And so we're going to write that as a ratio, and we're going to compare that to the ratio of the other triangle. And what you'll notice is because they're similar triangles, the ratios are going to be the same, about 0.76, 0.77. Then let's do the green triangle. Opposite 50 degrees is going to be 7.45. The hypotenuse is 9.67. And so in that order, the opposite divided by the hypotenuse is going to be, again, about 0.77. And so these three trig ratios, these ratios are called the sine ratio. Sine is opposite over hypotenuse. No matter how large your triangle is, as long as your reference angle is the same, the ratio of the sides opposite divided by hypotenuse is going to be about the same number. So slide 18, what do we notice about the ratios? The last column on the previous slide. All the numbers are about the same. They are about 0.76 or 0.77, depending on how we round. Let's not round all the way up to 0.8 because that is rounding too much. We always want to round to 3 or 4 decimals. So we have our ratios. It's not always opposite and hypotenuse, but it is going to always be the lengths of two sides. We know we have similar triangles because of angle similarity that we did before spring break. So we have sine, cosine, and tangent, and they're all different in a little way. You have pictures below. You'll also have a reference sheet on your state test that is going to have the ratios spelled out for you. Sometimes you'll hear it called SOHCAHTOA. The SO stands for sine is opposite over hypotenuse, and that's opposite angle B. The cosine is adjacent to angle B divided by the hypotenuse, and the tangent does not use the hypotenuse at all. So if you're ever doing the tangent ratio, you're going to divide the opposite number divided by the adjacent number. And remember, if you ever switch your reference angle, you would be looking at different numbers for your opposite and adjacent. Hypotenuse is always the longest side. You can think of these sine ratios, cosine ratios, and trig ratios as functions. Okay, so all right triangles with 50-degree reference angles will have the same ratio, okay, in terms of sine. So trig is a function machine that takes angles and converts them into side ratios. This function machine is sine. So sine of 50 degrees, you're inputting it and you're outputting a number, approximately 0.766, which is just like we saw on one of the previous slides. That means for every right triangle with an angle of 50, no matter how big or small, the ratio opposite over hypotenuse will always be 0.766. So let's try to type these in the Desmos calculator that you'll see in your state test. So there is a calculator at the top of every screen within this Desmos activity. Okay, and that is degree by default. You'll see the DEG. Don't click that ever, ever, ever. Keep that there. Okay, I'm going to show you the Desmos calculator outside of this Desmos. So click on Desmos calculator, and we're going to go through how we set that to degrees. I just need to figure out how to get my tab to go over. So stay tuned for another video to show you how to change to degrees in the Desmos calculator. I'm recording a tab and I cannot switch to the other tab. So we'll come back to this. For now, we'll use the calculator in the Desmos activity. Again, we'll get another video out that shows you how to use the OST Desmos outside of this activity to calculate sine, cosine, and tangent. So when you have a trig function, you just type it in, like sine of 32 degrees, okay? If you're using your phone, you do type it in backwards. You would push 32 and then sine, but we're gonna try to get away from our phones and use either the calculator in the Desmos or desmos.com/calculator, which is right here. And it does show you to click on the wrench at the top and then click degrees. And we'll get another video out for that. So sine 32, you have your calculator here. It's already in degrees. If you open the Desmos calculator outside of this activity, make sure you click the wrench and then click degrees. But right now we're okay. So sine 32, and then we want to round 0.5299, or you can round up to 0.530. We always want to do 3 or 4 decimals. And so that means any right triangle with a 32-degree reference angle, the opposite side divided by the hypotenuse will be approximately 0.5299 or 0.530 if you divide those sides. So the cosine of 46. Again, we can just type in cosine 46. Okay, it is in degrees. Okay, don't push that button. If you are to go to the Desmos calculator outside of this, make sure that you click degrees after you click the wrench in that toolbar. So the cosine of 46 degrees is 0.6947 because there is a 5 after the 6, or 0.695. Since 7 is above 5, we're going to round up. And so that means any right triangle with a 46-degree reference angle, if we do the cosine, which is the adjacent side, divided by the hypotenuse, will approximately get that number for the ratio. And so that's just using the calculator. Now we're going to set up the ratios when we don't have a number for the reference angle and we're just looking at the sides. So on these next 2 slides, we're just setting up a fraction. We're not typing in the calculator at all. So let's use angle A as our reference angle down in the corner. The sine of A is the ratio of the number opposite, which is 3, divided by the hypotenuse, which is 5. Now we can do other ratios. We can do something called a cosine. So I start at A, and I don't go opposite, but I pick the number adjacent, which is 4, and I can divide that by 5. And the tangent does not use the hypotenuse at all. That would be the ratio of opposite, which is 3, divided by 4, which is the adjacent side. And so now on the next slide, we're going to change to angle C, and we'll go through those angles. So if we have reference angle C, we want to do the sine, cosine, and tangent of those. It's the same setup, just different numbers. So we're going to do the side opposite angle C. So opposite angle C is 4. And we're still doing the hypotenuse. Opposite over hypotenuse. So you can notice when you switch the angle measures, you're switching your top number. The sine and the cosine are related to each other because when you switch your reference angles, you can switch your sides. cosine of angle C. So if I'm at angle C, I want the side adjacent, which is the closest to angle C, which is 3. And cosine is also divided by the hypotenuse, adjacent to the hypotenuse. And then when we do tangent, angle C, we're doing the side opposite angle C, which is 4, divided by the side adjacent. So tangent never uses the hypotenuse. And you can see that when we had angle A, it was 3 over 4. And then when we're switching to angle C as our reference angle, now it's 4 over 3 because our opposite and adjacent will switch. And so those are your notes, slides 16 through 25.